6.3 areas under any normal curve. Steps to find any area probability for a normal distribution. We will be converting raw scores into our z-scores and finding the probability using that standard normal table. So this is building off of 6.1 and 6.2 still, obviously. We're going to find the probability of x being greater than 2 when the mean equals 3 and the standard deviation is 0.25. So this is, you have to remember, if we have a greater than symbol, key things to remember from 6.2 that we learned is that this would be shaded to the right if it's a greater than symbol. So we're going to have to take 1 minus our value, but we have to go find the z-score now is the only new thing that we're doing in 6.3. So we know that formula, our z-score formula, is taking our x value, which is 2, minus our mean, which is 3, and putting that over our standard deviation of 0.25. If you want, you could write that z-score formula up here. If you didn't remember what it is, it's our x value minus our mean divided by our standard deviation. So when we do that math, you're going to get a negative 4.00. So after you find this value, this is when you're going to go to your table. Now remember, anything less than negative 3.49, which this table doesn't go to the negative 4s, right? So that's when we use 0 in that fine print that we learned the very last thing of our 6.2 lecture. So our table value would be the 0.000. Well, what does that mean when we're answering this question? The probability of x being greater than or equal to 2 means that we're taking 1 minus 0, basically. So the probability is 1. It's going to happen. If you were to draw that curve, you would be shading everything underneath it. I'm not going to draw the curve right now, but that's what that would mean. Remember, this would be an example of a between. So this is a little bit of a review of what we learned before. While we're adding, we have to find the z-score. So these are our x values, 10 and 26. I'm going to do the bigger one because you know we always subtract the bigger minus the smaller anyways. So I'm going to work with when the x part is 26. So we have 26 minus our mean of 15 divided by our standard deviation of 4. Plug that into your calculator, you get 2.75. Then we're going to go to our table and we're going to find the probability from our table. I'll pull it out a couple times this here. So 2.75. So we get 0.9970. I was on the wrong one. 0.9970. Okay, now we're going to do for when z was 10. So 10 minus 15 divided by 14 gives us a value of negative 1.25. Go to your table again. I'm going to pull it out just for practice again. I probably won't every single time. And I really encourage you to pull out your table and do this yourself. Pause, see if you're using your table correctly, because that's an important thing. So that would be 0.1056. So remember, when it's a between, we are subtracting the two probabilities. So we're going to be taking 0.9970 minus 0.1056 to find that probability of between, I'll write it down, 10 is less than X, which is less than 26. And when you subtract those two things, you're going to get 0.8914. Remember, if it was just a less than symbol, you just use the table value, but that just refreshed your memory on the two that are slightly different. If you have a greater than symbol, you need to remember to subtract from one. If it's a between, you subtract the two probabilities. So let's apply this. Police response time to an emergency is normally distributed with a mean of 8.4 minutes. And a standard deviation of 1.7 minutes. So they're going to say, what's the probability that the wait is going to be between 5 and 10 minutes? So I'm going to, and you could write it like this if you like. Oops, this should be a 5. That's what we did below. So our 10 minutes, or actually, yeah, let's do our 10 minutes. We'll be taking 10 minus our mean of 8.4 divided by our standard deviation of 1.7. And so 10 minutes, when you do that, it would be 0.94. And then you go to your table, and the table value that correlates with that is 0.8264. In 5 minutes, so 5 minus 8.4 divided by 1.7 will be negative 2.00. So we go to our table, and the value you're going to get for that is 0.0228. So to find that probability, remember, we're going to be subtracting those two. We're going to be taking 0.8264 minus 0.228. So to find that probability of 5 is less than X is less than 10, when we subtract that, we get 0.8036. Then they want to know, what's the probability of the wait being less than 5 minutes? So what does that look like? Less than 5 minutes. So since it's a less than symbol, we just get to use the table value. Since it's a less than, because remember, z-scores are shaded left anyways, and that's what represents the less than. So we're just going to be looking for probability of X being less than 5. So our z-score, we're doing 5 minus our 8.4 divided by 1.7. So the z-score would be a negative 2.0. And so we just use that table value. We don't have to do anything or any additional operation because it's not a greater than or a between. So the probability of X being less than 5 is, from the table, 0.0228. 0.0228. I know I drew my box kind of around that pretty tight. So let's turn the page and work with this a little bit more. The cassette deck life is normally distributed between, or with the mean of 2.3 years and a standard deviation of 0.4 years. We want to know the probability that a cassette deck will break down during the guarantee period of 2 years. So we need to find our z-score by knowing that it says it's going to break down during the guarantee period of 2 years. So that means anything less than 2 years, they guarantee it's not going to break down. So we would think of this as like X is less than 2. So you have to think a little bit of what it would mean in terms of a less than or a greater than symbol in this 6.3. So our z-value is going to be a 2 minus our mean of 2.3 divided by our 0.4 standard deviation. And so that's going to be a negative 0.75. We're going to go to our table, and since it's a less than symbol, we get to use that value. We don't have to do anything different because of the less than value. So this is like saying the probability of X being less than 2 years. When you go to your table, you go to your negative Z table, you go to the zeros, 0.7s, and then over to 5, and you get a 0.2266 value. So inverse normal distribution, we will be using the Z table a little bit backwards. So just like what we just found with this one. If we were going to our negative Z table, I'm going to pull it up here and we go to negative 0.7, and then we find our 0.5 column. That's right here. That was the value we wrote down on our paper. Well, now we're going to be using this table backwards. Maybe we know the probability is 0.1056 of something. And we're going to have to find, well, what z-score does that correlate with? So it's just finding the number backwards and saying, well, that would be a negative 1.25. So you'll have to look at a lot of digits when you're doing this. So steps to find a standard score, z-value, and or the raw score, the x value when the area or the probability is given. So I just kind of showed you that on the table. You're going to find the area inside the table and look to the left and the top to find the z-value that goes with it. Then we might need to, in the next step, convert that z-value to an x value if we want a raw score. That just depends on if they're asking for our z-value or our x value. So now this one says, find z such that 5.2% of the standard normal curve lies to the left. So that's important verbiage. So to the left, that would also kind of think of less than. This is when you're using the table value. So it says find the z such that 5.2% of the standard normal curve lies to the left of that. So what would that look like on the curve before we get started? Just want to give a visual. So this would be 1 standard deviation, 2 standard deviations, 3 standards. And if you think about 5.2%, that's going to be somewhere between here. And how do I know that? Remember, like this only represents 0.15%. This only represents 0.235%. And then this one, we start to get closer, like if you were adding percentage. So it has to be a little bit to the right of -2 standard deviations is what that represents picture-wise. Like we're just a little bit to the right of the -2. And that would be like 5.2%. And it's saying to the left. So that's how we know we're using those scores. So we're going to have to convert that to a decimal because we're going to go to our table. And that's going to be like we slide 2 places to the left, 0.052. And you always see 4 digits. So you might go ahead and put a 0 at the end of that one. So this is what we're looking for on our table. And it's in the negatives. So that's how the reason I wanted to draw that is because you're going to be looking at your negative z-score table because it's to the left of that. And 5.2% of the area, what we learned about when we added them together would be over here. So we know we're in the negative z's. So negative, and it's somewhere between, -2 and -1 to find those values. So we're looking at 0.052, And so sometimes what you're going to find is you don't have the exact number. Sometimes it's going to be in between. And what we do is we just compare and choose which number it's closest to. So like 0.0520, I'm going to write these two things on our paper in a second, but this probability represents negative 1.62, and this is negative 1.63. But our value, let's go ahead and write it here, just to simulate the table a minute, because you can't look at both at the same time. So I said this represented a negative 1.62, and this represented a negative 1.63. So if you're talking about on the number line, this is only 0.04 away from that. That's 0.0, that's a 6. Like if you just subtracted 20 minus 16, the difference is 4. 20 minus 26, the difference is 6. So it's closest. So we're going to compare which number it's closest to. And so since it's closest to that one, we would call this a negative 1.63. So it's not exact, but it's pretty close. And that's how you won't always find every single digit possible on the table. But that's what you'll do if it's not on the table. You compare and find which one it's closest to, and you use that one for its z-value. Find z such that 5% of the normal curve lies to the right. So this time we're saying it lies to the right of it. This is when we need to remember, this is when we find the complement of what we just find, right? One minus, or think about percentages. That's like saying 100% minus 5%, which really is representing 95%. Or you could have turned it into a decimal. 1 minus 0.05 is 0.95, because this is what we're really working with, the probability, the decimal form. So we're going to go to the table again, and we're going to be looking for 0.9500. So if it's to the right, let's look up here, it would be in the positive world, right? So we know we're going to be on the positive z table. And let's go find 0.9s, 0.95s. So it looks like we're right here. 0.9495, which is 1.64. 0.9505, which is 1.65. Let's write that down on our notes so we can know what we were looking with on our table when we look at our notes later. So I said this was 1.64 and this is 1.65. So in this case, there's not one that it's actually closest to, because this is 5 above and 5 below, right? So in this case, if they're exactly the same amount apart, you're going to find the average. So when you compare, if they're the same, that's an R. When they're the same, you have to find the average. So we average out 1.64 plus 1.65 and divide it by 2. So we average out the z-score. And so that z-score would be 1.645. So you do end up getting a 3-digit z-score if you ever have to average them. Okay, let's turn the page and move on. It says find z such that 90% of the standard curve lies between So we get to keep working with less thans, greater thans, and betweens forever and ever. So it says if it's 90%, meaning 90% is shaded. That's why I like to draw pictures most of the time. Sometimes it gets kind of time consuming, but it really helps. But 90% is shaded. So what that means is if you take 100% minus the 90% that's shaded, that means 10% is not shaded, right? So there's going to be two sides of this. If it's between, you have two sides. So if 10% is not shaded, you're going to divide it by your two sides. And so that means 5% on each side is not shaded. So we are going to go find, we could just find one of the z-scores, right? 5%. Let's maybe draw it actually. And remember, 5% is somewhere between our -3 and -2 z-scores. It's kind of like right here. We're going to call that 5%. So if we have two of those, right, 5% above and 5% below, that area, that's what's not shaded, even though I did just shade it. But what we're trying to find is what's going to be in the pink. So what we should do is go find on our negative z table, go find the 5%. So 0.0500. Let's go do that. And when you do, you're going to, on your table, notice it's a between. It's a 0.0505. And then here's our value that we're looking for. And then the other value is 0.0495. So this value correlates with a -1.64. And this value correlates with a -1.65. And so whenever we find z, the z-score that correlates at that, we can do the positive and the negative form of this. But we really only have to work with one because it's exactly the same on the other side. But we need to find what the z-score it is. And again, this is like 5 below and 5 above. So we have to find the average again of those z-scores. So 1.64 or -1.64 plus a -1.65 divided by 2 means our z value is a -1.645. But WebAssign is always going to use the positive value. So they're going to say it's between these two values, but it's going to be a negative and a positive. And that's because they already say the negative z value. And so if you were to just replace a z with 1.645, that would represent it as a negative, and the z value, when you replace it as that, it would be the positive value. So you're going to answer in this one, the z value will always be just the one positive. There are two z values. They're exactly the same because it's 5% to the right and the left. So it's exactly the same. And it's just representing this area between the two z values. But that's all we're finding is the area between the two z values, or the z-scores that correlates with that. And you're going to always use the positive z value. You don't have to put them both because of just how it reads with the z's. So in WebAssign, that's a tip, a WebAssign tip. Always use positive z values. All right, so then what if it says find the probability of x is less than blank equals our 12.3%. So we're trying to find the raw score now. So we have a little extra step in the ends. We're still going to our table value and finding 0.1230, right? We just changed that to a decimal to know that we're finding that. And so since it's a less than symbol, let me make sure I talk about that. Those are all things you have to look at every single time. We know we're using the exact table value. We don't do anything different. So use the table value because it's a less than symbol. When we go to the table, I'll just say use this one, use table value again, just writing it twice, I guess. We will find that it is an exact one on your table. Let's go look. It would be in the negative realm. And if you think about a normal curve, 12.3%, you know, if this is your mean, right, this was 34%, 12% is less than that. That's going to be somewhere over here, right? So it's going to be in the negative z values. That's how you know how to find. You still go back to understanding the percentages that separate your bell curve, that empirical rule. So we're going to go find 0.12. What was it? I already forgot the value. 0.1230. 0.12. I'm probably skipping over it somehow because my eyes struggle. Right here. 1.1230. It's an exact one, so negative 1.16. So it's an exact value. But they want to know the x value. So we first find the z value, then we do that x equals your z-score times your standard deviation plus your mean. Okay, so my z-score, gonna have to do a little math here, was negative 1.16. My, they gave us, oh, this example, yeah, I wrote it above. I was like, where's my mean and my standard deviation? Sorry. Here, this information goes with our problem. So they're saying, example, the mean is 17 and the standard deviation is 2. So negative 1.16 times my standard deviation of 2 plus your mean. So you'll always be given those other two things when you're finding the x value. So whenever you do that math, your x value is going to be 14.68. So it's just a way to fill in the probability of x being less than, and we just found that. That would go right in there. Means, and I didn't leave enough space to really write it, that it equals 12.3%. But you'll just be typing it into the box. But yours would be at 14.68 that you would type into that box. So last example for the 6.3, a video game company wants to advertise a guarantee policy that will refund the full price of a computer if it fails during the guarantee period. The mean life for the computer is 28 months. With a standard deviation of 5 months, the computer life is normally distributed. So we're going to have to be working with our z-score formula in this one. It says if the company guarantees a full refund on a computer for 2 years, so meaning you've had it for, if you've had it less than 2 years after purchase, what's the percentage of its computers will the company expect to replace? So they're going to guarantee for 2 years that there's not going to be any issues with the computer. It's not going to fail on you. So your probability of X being less than 2 years, meaning the computer fails at this time. So because of the less than, we're going to use the table value. Since we're talking about months, notice that our units of time are in months. If you were to just run with 2, they're going to think that's going to correlate with just like 2 months, since all these values right here are represented in months. So you need to change that to 24 months. So the probability of X being less than 24 months, put them in the same time unit. And then do the math. So 24 minus a mean of 28 divided by 5 gives us a negative 0.80. So we're going to go to our table for negative 0.08, and we get to use that value. So that would be 0.2119, but it does say doesn't really say if they want a percentage or the probability. So you would either answer it as a decimal, or they're probably going to be thinking more like a percentage. Oh, it does say what percentage of its computers will the company expect to replace. I really looked over that when I was quickly scanning again. So 21.19%. If the company does not want to make refunds on more than 12% of the computers it makes, how long should the guarantee period be? And then it has to be, to the nearest month. So we're going to have to use the table backwards on this one. This would be application of why we learned to do this. We want to know what 12% of the area represents for this problem. So that'd be like saying 0.1200. So we have to use the table backwards with this 0.1200. Now it lies, when you pause this video and find it yourself, please do that right now. It's going to lie between 0.1210, and then here's the one that's ours, and then the other one is 0.1190. So this correlates with the z-score negative 1.17, and this correlates with negative 1.18. And so they're the same above and below in difference. So we're going to have to just average those to negative 1.17 plus negative 1.18 divided by 2. And so that's going to give you, I'm going to actually move this direction because I don't have a lot of space right where I wrote that. That is a z-score of negative 1.175. So we did all this first to find that z-score, but what we're needing to know is months. So we need to convert that to a raw score. So we have to find the z-score first, then find the raw score. And so I'm going to put this as my second step in this little box, since it's kind of working backwards. So you have X equals your z-score times your standard deviation plus your mean. So negative 1.175 times my standard deviation we said was 5 months plus 28. And so X would need to be 22.125 months. So they said round to the nearest month, so 22 months. I rounded that to a whole number.